Welcome back everyone to session 3 of Agro Robotics Lab. In the last two sessions, we learned how the robots grip the tomato stems using the servo and the push button. Now we are going to give our robot something just as important as hands, the ability to move and navigate. We are going to use the platform called VEXcode VR. In tomato crafting, robots need more than just a good gripper. They must move more precisely to the correct location of the stem. Even a tiny misalignment, just a few millimeters, can make a graft fail. Farm workers do this by eye and hand, and robots, however, must do it using movement commands, sensors, and precise navigation. So in the VEXcode VR, we are going to follow some block codings. Let's understand by giving two different commands today. The first one, when started, drive forward for 200 millimeter. When started, so this tells the robot what to do as soon as you click the start button. Drive forward for 200 millimeters. The command is very clear. The robot moves straight ahead 200 millimeters. Then it's going to turn right. So the robot makes a perfect right angle turn, just like turning into a new row in a greenhouse. Drive forward for 200 millimeters, so the robot continues moving to reach a new position. This simple sequence, it teaches our robot how to approach the tomato stems by navigating around the greenhouse floor. And let's go even more detailed work in VEXcode VR. When started, drive forward for 200 millimeters, stop driving. Again, drive forward for another 200 millimeters, stop driving. So what's happening here? Initially, we are driving for 200 millimeters. This is like stopping at a plant 1. This is our first graft point. Then drive forward for another 200 millimeters and stop at plant 2. So this is the second graft point. Drive forward for another 200 millimeters and stop at plant 3. Turn left, turn right or left to 90 degree and drive forward for 200 millimeters. So this ensures that we are reaching the side plant. Turn around for 180 degree and drive forward. So this is like returning to the starting point. So these single commands, it's going to act like the foundation steps for the real agriculture robots. So it's like moving down in a row, turning into a next row, reaching the crafting position, aligning with the plant stems. So every advanced robot starts with a basic navigation like this. The purpose of stop diving block here. The stop driving block is used to completely stop the robot motors after the movement is finished. This is going to ensure the robot comes to a full controlled stop before starting the next command. It is needed in order to prevent the rolling off or drifting or making the movements more accurate, and it is useful in the multi-step path. So before a turn or after a solved segment of a movement, we tend to use the stop driving. Here particularly, you might not need a stop driving because if you use drive for 200 millimeters, it already stops, right? But this block is more useful when you use drive forward or when you want to drive in a particular direction or drive continuously. With this ideology, let's go to the platform now. Go to Google and type vr.vex.com. There are a lot of options available here: drivetrain, magnet, drawing, sensing, console, logic, and switch. Today we will try to use logic and drivetrain, and in our upcoming classes, let's explore the remaining options as well. So in the logic, scroll down and choose when started. When started, this is going to tell the robot what to do as soon as you click the start button. You can find the start button at the right top. You can choose any of the playgrounds here. And today, I'm going to choose Art Canvas. So when started, that's our first command. Let's go to drivetrain and give drive forward 200 millimeters. The robot is going to move straight ahead 200 millimeters. Just click Start Simulation. You can witness the robot move straight. Stop the simulation and try to run it again. Next, let's give the next command. Turn right for 90 degrees. Let's stop the simulation and run it. You can see the robot has tried forward for 200 millimeters and then it turned right for 90 degrees. There's a perfect right angle turn here. Next, drive forward for 200 millimeters. Let's stop the simulation and run it again. You can witness the robot drive forward for 200 millimeters, turn right for 90 degrees, and then it drove forward again for another 200 millimeters. So this is how we can use the programming blocks in the VRVEX.com and do the navigation challenge. So this is one of the simplest navigation challenge what I have taught you. Now it's time for you to look into this complex navigation challenge. So the goal here is to make the robot visit multiple plants in sequence and then return to the start. That's the reason why we have given 600 millimeters as our last command. Try to explore the tool and complete this complex navigation challenge. Until then, see you all in the next session. Happy learning.